Good afternoon and welcome to Webinar Wednesday. We're certainly glad that you could all join us for a very exciting presentation sponsored by RTI Group. But before we get started today, I know we've all been faced with some news of a very tragic event that took place outside of San Antonio, Texas yesterday afternoon. We think it is best, just while all of our hearts are heavy and our minds are on what this town of Uvalde, Texas is facing, and as a nation, what we're now talking through again and looking at together. Let's just have a brief moment of silence, raising up positive thoughts, vibes, or prayers for all of those that are affected. And then we'll get started with the webinar today. As mentioned a little earlier, our sponsor today is RTI Group, and we certainly want to thank them for bringing this webinar to the TechNation community. We're joined by Erik Wikström, Key Account Manager at RTI. RTI provides complete quality assurance solution for all X-ray modalities and facilities. Click and go solutions for your X-ray QA. The TechNation team is headed out, as many of the HTM professionals and biomedical engineers are, to the San Antonio, Texas area, June 3rd through 6th for the AMI Exchange. We want everyone to RSVP to pick up your trade show survival kit filled with items needed while you're on the road. Visit onetechnation.com/AMI for more details, and stop by our booth number 1026 to pick up your kit. Today's webinar, as always, is eligible for 1 CE credit from the ACI. You can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after today's presentation. You must complete the survey to receive your CE credit. And if you have any issues, you can always email us at webinar@mdpublishing.com. As I mentioned earlier, Erik Wikström will be our presenter today. He will illustrate what can be achieved with the help of modern, fit-for-purpose instruments, probes, and SW, combined with efficient procedures. Erik, you may begin whenever you're ready.
Well, thank you very much for this opportunity to present what we have learned from the field and from customers that have been using our equipment, and sharing their experiences with what has been useful to them. First, a little brief introduction about RTI Group. In the meantime, I'll turn the camera off so we can focus on the presentation. There we go. RTI Group, a little bit of a background where we come from. We've got, let's see if we can advance the slides. There we go. We're a company that works globally. We have coverage across the globe. Our head office is up in Sweden, and this shown here in this map on the west coast of Sweden, Gothenburg, outside Gothenburg. We have a sales office down in Singapore to cover the Asian Pacific market area. And of course, also in the USA, that's our oldest field office globally, outside of Tuaco in New Jersey, where we have sales office and also service and calibration facilities for the North American market. History is such, you may have heard about it before, but we're the pioneers of non-contact measurement of data in the KV, in the X-ray field. It started off in 1982 with this piece of kit here called the DigiX, which was the first non-invasive, non-contact KV meter that made the job easier for a lot of people who had to rely on dialyzer or similar kits for voltage dividers that they had to carry, and they're heavy and cumbersome to install. Took a while for that to take hold on the market, but once it did, it was quite popular. Saved tons of time. Just putting this here, the detector, which is this, into the beam and making an exposure that will give you both the kV, dose, and time for the exposures made. As time went, the equipment became smaller, more portable, also more flexible, with PMX devices, PMX1, which is an even smaller, again, the detector, same form factor or same type of shape. And then we've got the PMX3, where you've got both the RAD and the MAMO, as well as external probes used in the field. So this was the 90s. Moving on to this century, we have the Barracuda, which was the first device in the market with multi-probe configuration, where we had a base unit and a readout, with handheld or computer-based, and then the possibility to attach external probes to make the measurements that were necessary. That was then followed by the Piranha, which was a condensed version of the Barracuda, self-contained, battery-operated, Bluetooth, with a built-in detector right here, and the possibility to add external probes as well. Moving into today's product portfolio, we've got quite a broad range. The basis remains the same, where we have built-in probes with built-in communication with batteries, battery-operated. With the Piranha family here works with an external software and an external display. And we've got another family, the Cobia family, which we'll look a little bit closer at, which has its built-in display. There's a wide variety of external probes to catch dose, maybe in a smaller place like in a bucky, or if you need to attach it to a wall stand to get a second dose or a primary dose measurement. These all attach to the Piranha or the Cobias for the readout. CT probes as well, the normal CT ion chamber, that's 100 millimeters. There's a bigger one also, 300 millimeter, that covers the wide beam CT measurements. CT dose profiler looks like an ion chamber, but as a matter of fact, a solid state detector with a single point detector here, where you can use that to measure the beam width. The detector itself is 0.25 millimeters big, so you poke that through the CT beam and sample the dose. And if you know the speed of travel, you can recreate the dose profile of the complete X-ray beam. Thanks to the versatility of the system packaging, we can attach also DAP chambers and other ion chambers apart from the CT ion chamber to measure, for instance, MAMO dose with ion chambers, or DAP or CAP measurements made in panoramic or CBCT dental, for instance, where it's difficult to measure a decent CTDI value due to the fact that many of those gantries don't perform a symmetrical scan, have a non-circular shaped movement of the gantry. So this smaller one is suitable for that. You place that on the tube side and measure all output from the tube. So you get the DAP value that way. There's a larger one here that fits into the normal rails in the collimator in a normal RAD tube, so that you can actually check the built-in DAP chambers that are fitted in many cases in in situations like that. So the DAB chambers can have 2 calibrations, one for entry dose and another one for exit dose, so that we can determine the calibration and the readings and verify the readings on built-in DAB chamber, if that's necessary. We've got mass probes as well, apart from the mass 1, which is an invasive. We have a non-invasive mass 2 probe that clamps on to the high tension cable. We'll look a little bit closer at that later on. And one that isn't shown here is the MA test point cable. We'll look at that as well in a while. And finally, there's a light probe that doubles as measuring the luminance from a screen to see that the output from the screen is as it should, that it conforms to the values in the test patterns that are determined for that. And using a small diffuser, fitting that onto the light probe gives us the possibility to measure the ambient light and the collimator light to verify the collimator light intensity. So this is the package. This is the probes that we have, and the latest addition to it is, of course, the scatter probe, which we introduced last year, which, of course, as the name tells you, that it measures the scatter. So it's used for scatter and leakage measurements in the X-ray field. And what we have here is the first, or one of the few, with 100 square centimeter effective area to measure, which conforms to the regulation in this field for leakage and for scatter. And there's also the 10 square centimeter, which is required in some of the regulations for secondary radiation, barrier radiation. So that's the range that we have for meters and probes, and we'll look a little bit closer at what they have to offer. They have been in use since quite some time. We have customers out in the field that are happy with them. They're using them in their day-to-day work for R&D, for repairs, for maintenance, and also for the field engineers out in the field. So what we offer, what is also a useful tool, is have a supplier that provides, for instance, fast calibration service, where we today have a turnaround time of about 8 to 10 days when it comes to calibration. Our recommended calibration cycle is 2 years. So that's what we find is a decent time. Of course, it's up to the customer to determine the calibration cycle, how often they need to calibrate their equipment. But our recommendation as a manufacturer is once every 2 years. There's a warranty extension program as well, where if you maintain the 2-year calibration cycle, you can extend the warranty up to about 10 years. And of course, responsive support team. If you're run into trouble, if there's a problem that you're facing, you need to have some fast support to get you out of that trouble, and that's something that we pride ourselves in being able to provide. So that's also something that we consider tools that are helpful in this trade. All right. So how does that fit into the field of biomedical technology? Well, as a biomedical engineer, this is quite a vast and diverse work environment as far as we've understood. When we come across biomed engineers, well, this is something that could be a description of it. I just took the liberty of trying to find well-defined work description, job description for a biomedical engineer, and it's quite long. But there are some things here where we touch on the same area as biomedical engineers. When it comes to, for instance, looking at the quality assurance for radiology devices, periodic action plans and maintenance, documenting what has been done into a database, installing, testing, calibrating, completing preventive maintenance schedules, equipment service, etc., etc. So there are things where RTI products can come in handy, are used, and where we try to make that part of a biomedical engineer's life a little bit easier. And what is that? Well, in the biomed team, it's they contribute to the safe use of X-ray equipment, to train local staff, and to make sure that everything is up and running and work as it's supposed to be. So that's preventive maintenance as well, making sure that the equipment is up and running and working the way it's supposed to be. Some also do repairs, and that would then be the first line repair before the manufacturer comes in or the third-party service organization comes in and does the larger repairs. QA testing, some of that falls onto the shoulders of the medical physicists, but some parts of it are also fall under the responsibility of the biomedical team as well. And maintaining records of the inventory, not only what hardware is there, what machines are there when it comes to X-ray machines, but also monitor the trends of how they perform. What's working well? Is there any certain tube that ages quicker than others, or generators that maintain the accuracy longer than others, or deteriorate quicker than others? So that's information that could be useful for the biomed team, so they can alert and plan their work if repairs need to be done in the future. So we see some of these things, these actions, these areas of responsibility growing and becoming a little bit more important, and that's where we are trying to provide help in those areas. So again, looking at the useful hardware, well, Piranha has been around for quite some time, and just again recapping a little bit of what we have. There's a standalone unit with a detector area, built-in detectors area, where we get the KV, we get dose rate, exposure time, HPL, and total filtration, all in one shot, based on the radiation captured onto those that detector area, which is right there. We have a port for external probes, which is on the narrow end. And those external probes can give us dose with the external dose probe, MA and mass with the mass probes. CT ion chamber connects there through the chamber adapter. Light probe also attaches there, as does the CT dose profiler. And these are some of these probes can then provide data at the same time as the detector area itself, so that we can get both KV, dose, and MA, for instance, in the same shot, if that makes sense. Some, for the CT ion chamber, for instance, doesn't really make sense to measure anything else than CTDI in that area. So for that, there's no combination effect or combination benefit of combining data for Piranha. Handling is pretty simple. I just made a picture here just for scale. Place it in the beam, power it on, and you see that the status indicator goes green. You have a blue for Bluetooth, because there is no cables attached to this one, because many of our users are happy with using the Bluetooth connection, which does take some time in setup. And once that's done, make your exposure, and you get the data. The data is then transmitted via the Bluetooth link onto a software which we call QuickCheck. It's a display that shows the values of the latest exposure. We have waveforms, and there is also a log or a grid that shows you all the exposures made in that on-off during that on-off cycle in the QuickCheck. And this is then basically what constitutes an instrument. You've got a probe that receives some form of exposure, and we have a display to display the measured values. So this is basically the instrument that we offer in this area. But the QuickCheck software does a little bit more as well. It has a plug-and-play functionality that when you plug in the probe or change the configuration of the unit that you have, it follows and asks you what you want to do if you attach a dose probe, for instance. It will ask you, do you want to use both probes or just one or the other? So that you need to decide how to use that software. It is Windows-based. That means that you can run it on the field engineer or the biomed tech can run it on the laptop, which most of them carry anyway. So there's less to carry around, and the data is then stored locally on that. There is a possibility to export to Excel, not only during the measurement itself, but also afterwards. You can do the exposure or the export to Excel once you're completed, or you can do it during the exposure and exporting data by data during the exposures. There's a possibility to share data with your colleagues. So just share, whoever has another instance of QuickCheck or on the software can receive this, open it, and see exactly what the user saw at the time of exposure. So you can help troubleshoot if that's the case. There's a simple reporting function included here as well, where we'll look at that in a little while. And a new thing here is also a possibility to tag data that we're measuring here. So we can add a tag to measurement points so that we can keep track of certain measurements in another view. So looking at the reporting function, this is what the built-in reporting function is. It simply gives us the data from the exposures, all the data that we can present, also shares and tells us what instrument was used, what serial number on that was used, so we can have that for traceability purposes. So this is then again what constitutes QuickCheck, or the larger parts of the QuickCheck software, making it an instrument. That's the way we see it. Of course, Piranha has a possibility to work in multi-modalities, depending on the version of the Piranha you get. Here is a view of what you see when you start up Piranha Multi, which is a multi-modality, and can give you both radiography, fluoroscopy, mammo, CT, and dental modalities. And the screens will adapt, of course, to those specific modalities. In fluoroscopy, there'll be displays for frame rate, and etc. For mammography, there will be possibility to select target filter combinations in the appropriate manner. So they're custom made for the usage areas that they're in. Then we have another piece of kit, which is the Cobia instrument. Also a little bit of a small brother to the Piranha. The biggest difference here is that it's a single modality. It's only RF As you can see here, the designation here is the Piranha Flex and RF. So they're only available for RF and dental, of course, but that's a RF variant. The other big difference is, of course, the built-in display, which the Piranha doesn't have. So the detector is built in with the crosshairs on it, and that also then gives you KD, dose rate, exposure time, HPL, and total filtration, as does the Piranha. So it's a basic tool for X-ray testing. That's like any other tool on the market. What it does have also is a built-in mass function. If you can make out a small plug-in here, that's a 3.5 millimeter socket for the built-in mass. That is a possibility. Then we have a port for external detectors. Some versions of the Cobia has, some doesn't, it's optional. That's where we can fit the external dose probe, mass probes, CT ion chamber, light probe, CT dose profiler, and get similar measurements as we do out of the Piranha. So it can be quite a flexible instrument in this way. So it has its built-in display, and it's a very easy setup. Just place it in the beam. I just have my hand in there for scale and set it up for whatever you need, power it on, and it comes on default with the standard measurements. The built-in display gives you normally the KDP, and as default, it will then scroll after an exposure to show you the dose. If you want it in gray or Röntgen, you need to set that up in the user settings. Dose rate, time, exposure time, HDL, and total filtration. So these values will scroll through the display once you hear that information. All right. So moving on, we've got stuck. Right. So there's also then a possibility with the Cobias, the recent Cobias with the black casing. They're all fitted with Bluetooth devices, so we can have a wireless connection if you choose. Setting it into wireless mode, there's only one readout. Either it's on the display or we make a remote connection Bluetooth to a laptop running the QuickCheck software, and we get similar readings as we do from the Piranha. With the data that we're reading, KD, time, dose rates, etc., the waveform, and a log or of the latest readings. The only difference we see here is on the lower left corner that we have an icon that we're actually connected here with a Cobia. So that's the difference that we see. We have the same connectivity to Excel. We have the same printing of reports, saving and sharing of data as we do with the Piranha as well. So that's also something that's quite neat, quite good to have. The possibility of doing the measurements, the quick and the measurements that are not necessary to document using the display. And then for traceability, you can link it up with your laptop or to your laptop and record the measurements that you want to keep for posterity and for traceability purposes. All right. Then with that, we then look at some of the external probes. And we've selected quite a few which are a little bit unique and which seem to save some time for the customers that we have out in the field. That's the feedback that we do get, at least. And one of them is the MAS2, the clamp-on probe. So the way it works is it clamps on to a high tension cable. You make it 0 to get rid of any capacitive charges in this configuration here. The cables here are attached to a piranha, which could be in the beam. And you capture through the inductive properties around the high tension cable, you're able to pick out the mass readings. And this is what it looks like. So you've got the piranha in the beam, and so you have the normal piranha values in these displays, and then attached the MAS2 probe give you the MA and the mass based on the exposure time values that we've received. In the waveform window, we've got the KV, we've got dose rate, and we've got MA signals, so that we can analyze to see if there is something that needs to be done or something that looks strange when we move along. So it is quite an easy thing. There's nothing all we need to do is clamp it on to the high tension cable, and off we go and get a decent value for the mass values. Of course, there are limitations to what we can pick out inductively from a cable which includes shielding. So for those some measurements and some precise measurements, the invasive measurement is to be recommended. And then with the MAS1, this is what happens here. You plug it into your generator, you get the jumper disconnected, and you're actually measuring the real true MA value. And then again, these cables, they go to the generator, and this cable right there is connected to the piranha or the cobia. We talked about the MA test point cable earlier. This is what it looks like. It's actually then a cable here that attaches to piranha or cobia, and to that cable we've got some lab connectors, which then can be connected to, for instance, these tweezers or clamps that you clamp on to the generator controller board. And for instance, this is one example like this, where you have test points where you usually attach the oscilloscope. So here, if you can attach these to one of the test points in chassis ground, you'll be able to measure indirect mass measurement. You're measuring a voltage signal, 0 to 5 volt typically, which then scales to the actual MA signal. So that's a convenient way of capturing that value. And it does, if you're measuring it with a scope, of course, then you need to look at the ramp up and the ramp down and the signal itself, and do your own calculations many times. Here, the software takes care of these calculations along the way. So it's quite a convenient way of getting the MA and the mass signals. If you don't have a high tension cable available, and if it's tricky to reach the jumper points in the generator for the MAS1 connection. And of course here we're on the low voltage side of it, so it's not as scary as if you go into the generator itself and open that up. So that's the MA test point cable. It's the cables here. It's in this end of the cable there's a chip where the calibration factors are stored. So that's how we can get the proper scale factors from the voltage to the MA signal. And that's how that is determined. All right, and then we've got a light meter that is in two parts. In this thing here in this part here, that's the base of the light meter, so to speak. In this case, we've fitted a diffuser here for the ambient light, for the luminance measurement, and this just refracts the light in the ambient. A small screw there to unscrew and remove this part and install this tube which has a trigger on this point at this side right there for monitor light measurements. And the software, when we connect that light probe to a Piranha or to a Cobia, detects that. Of course, in these cases, it doesn't make sense to do a combined measurement. It's when you measure light, that's all you're measuring. So that's why these choices come up on their own. So choose between the ambient light or the monitor testing. And testing the monitor, this is the way it's done. There is a bit of a shield or a shading device to reduce the risk of getting any side light interfering with the measurement. And that doubles as an aim, so you can aim it this way and then pop the tube for say a monitor light into there and press to open that shutter and expose the detector for that light. And then you release the shutter, move to the next area in the test image, and keep going, and you're done. For the collimator light, we use the diffuser, of course, and place the probe in each of the 4 quadrants, and also in the ambient with and without the ambient light, the collimator light switched on to get the difference in between, and you go. And this is then the reading of the ambient light. You get it in lux. It's a reading. You can see that it actually does stabilize and then terminate the measurement, and so you have a stable reading in that for that value. And to be able to cope with everything, of course, you need holders to get the meters in the right position. For mammography, it's holders for the Piranha. We have one that fits Hologic and Fuji, getting the Piranha into the correct reference height for those. GE Essential has one holder as well for that purpose, so it gets the right height and also the right position, as we do for the GE Pristina. So those holders are designed together with the manufacturer, the GE and Hologic and Fuji. So those are available to make that job easier also. Don't have to measure, just get the holder, and so that with that holder you have the right reference height. Then there's some other miscellaneous holders that we found that are pretty popular. For Philips, that fit onto the holder onto their vascular and their cath labs. This is a holder. There's a rod on that EDL kit, and this goes onto there, and we have the dose probe in the right reference height. Or we can do the same with the Piranha, have the Piranha detector in the right reference height as well. So that's for Philips. Those are available for GE, and it's typical to find a GE or the vascular holder, which goes onto the vascular, the Innovas, that fits into those test jigs that GE have for that. And there's the same thing goes for the dose probe holder for the RAD, and sometimes also for the older mammography testing kits. So these are the ones that are referred to in the technical manuals of these manufacturers. For dental, panoramic dental is a bit of a squeeze. Well, we've designed one holder for the Piranha. It's with a strap. There's a suction cup in the back to keep it in place. So there's a strap it into place. Here you've got some fluorescent tape to help you position it in sideways, And we found that it's reasonably easy to get that into place. We've done some adjustments to it. If you look at from the backside, we can slip the strap into some slots on the rear. That makes it easier to fit it on the corner of some manufacturers have their detectors quite close to the corner or the edge of a detector panel, and by being able to move the strap to different places, we can get a more stable positioning of it in many cases. Nova Ruler is a device here also that is used to measure the light and field and X-ray field correlation. Has markers on it that you can then set to 0, where the light field ends or starts, and make an exposure, and then you can look and see how well does that match the X-ray field. Because of course you'll get that through they're metal. The clips are metal. Those clips. You can use it also without those markers. Make sure where you make a note of where the X-ray field or the light field edge is, and then make an exposure, and there's etched scale in the ruler, so that you can make a readout and do the comparison afterwards once you view the X-ray image. We talked about the scatter probe. It comes with a built-in stand that collapses, and it can be used as a holder or a handle if you want to do some form of survey measurement or move the probe, for instance, behind a lead glass, or look at leakage through door jambs or edges of the lead glass and into the controller area. It works also with the QuickCheck software, where you can select the mode of operation that you're facing. So it's either the air karma rate, which gives you gray or Röntgen, or the ambient dose equivalent, which gives you the Sievert values for it. There's also one not so much in use, but the possibility to measure and to determine the mean energy of the spectrum that you're facing with the leakage. So since there's not only the KVP, it's actually the mean energy of the radiation that's picked up, which comes in handy because that's what's being used to calculate the ambient dose equivalent from the air karma rate. You get a clear overview of the data as well here. You've got the dose values, you've got this bit of time. Of course, that's difficult to work with because it's may not be correlated exactly to what you have in your panel. But there's an image of the waveform as well, which can come in handy when you're troubleshooting in some instances. Right, so we'll leave the hardware then and move on to the software, and that software is Ocean. And what we've seen before is QuickCheck, which is the lowest version, the lowest license level of the Ocean software. Ocean is a package of software functionality. So the most simple one is QuickCheck. If we move up, we have Ocean Advantage, where we have possibility to design templates and that help us in the testing procedure. So we've got possibility to create favorites for which are customized to user situations, which can contain hints that serve as instructions for the user, reminders for those who are experienced, and also new instructions for those who are less experienced. Built-in reports, customized as well. We can save the data and build a database of the measurements that we have, from which we can share data with colleagues and why not with customers. And from that database, we can also create trends and monitor the trends in the population we have of machines. To handle that and to design these favorites and these templates, there is a studio to be able to help us customize this. Now, how would that work? Well, the idea is then to have the big part of users being technicians now, and then they need something simple to work with. So we could be looking at the favorites folder, and where the company or the hospital or the group would save the tests that are performed regularly. So under favorites, we could have KVP accuracy, we can have KVP dose and reproducibility, or PMs, or HHS tests, or whatever kind of tests that are to be performed. So if we select one, maybe the KVP accuracy test, we're then prompted and given the chance to select the data, a site from a database. If we've got a database built up, we can then say, okay, I'm in this certain clinic in this room, and here we can then from the database choose which of these customers am I at this moment. Well, I'm at RTI Electronics clinic, department 1, and in room 1, and then finish, and off we go. As it opens up, we have a prompt, or can have a prompt, if you like, to give instructions to place the piranha perpendicular like this with an image, for instance. Click OK to advance beyond that and to start the actual measurement. And these instructions can be anything. It could be a picture, it could be an instruction like this, where to attach. It could be an excerpt from a PDF file or text, whatever help you need that they would need. Once that's done, it moves in and starts getting ready for the first measurement of a KVP accuracy test. Some of you may have seen Ocean before, but this is a bit of a new view where we're looking at a test view, giving us the possibility to have the set values as a panel to the side with a slightly larger font. So that's easier for us to see it from a bit of a distance. And it shows the set values for the row we're at. In this case, we're looking at a test, a KVP accuracy test for 5 exposures, 50, 60, up to 90. SID should be 50 centimeters. This could be at any distance. The mass needs to be larger than 15. And what happens here is that we have the tube voltage collected from the instrument, piranha or cobia. The software will calculate the difference in percentage between the measured value and the set value and give us a result, pass or fail. So that's the idea behind this. And once it's ready to go, all we need to do is make the exposures, and this is what it would look like once we're done. We've arrived at the last line. Set KV is 90. We said we've got values. The result is pass, 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 pass. And to your lower left or lower right, we see that we have a result pass and some more information about what's going on. The maximum inaccuracy is 3.8% at 90 kV, which is this point right here. And the other, see these green dots, is a graphic plot of the deviation from 0% of the measurement. Since we decided to choose and correlate or attach this measurement, we selected a database or a site. The site was RTI Electronics. This information is then immediately imported from the database we had there before. which department we're in, which room we're in. We can make those choices, and that information will reflect in the report that is generated. If we have a preview of the report, this is what it says. So we have some site information that we had before. This is, RT Electronics and where we are. It's department number 1, room 1, fine. And in room 1, from the database, it's picked out that in the room 1 in that database, the generator is an ideal RF. It's from Sebical. It's an HDF, so serial number. The tube has a serial number of so much, and we also have the measurement values, the data from the measurement itself. So these are then default values that are available, and they can be customized in the report when it's done. Of course, you also get an analysis with the images that we had before with what went on. These measurements are then stored in a database, like we said before. So they will be stored here on the local device, but it can be shared with colleagues in the group by exporting the data as we move along. So once we've done and collected enough data in the database from all our different clinics, we can pool that information, of course, also into one big database. We can from there do trending to see how does, for instance, the value layer vary across the population we have in our hospitals, in our different clinics. And this is where we'd be able to see, okay, here is an outlier, probably that's a CT, here is a low, that's probably a mammography, and this one, what is that? And well, yes, it's a radiography, and this is where it was. Just if we hover over this, we can get information about where that was. So it's a quick way of getting access and to see how that's the database and how the equipment we have in our control, what they're doing, how they're performing. So to do this, to get these kind of templates in shape, we've got a studio where we can provide design of the different templates. We can add rows and columns. We can add analyses that will then give us pass-fail criteria or pass-fail during the test that we're performing. The criteria is set up and selectable, typical for X-ray testing. So it's for accuracy, for linearity, for reproducibility, etc. Those are all preset tests that can be selected. And of course, insert rows and modify the graphics and the look of it to get it to work according to the tests that the customer and that you as a customer would need to perform. With the latest release of Ocean Next, just a couple of weeks ago, we've added some web-based functionality. The first one here is a MyRTI. So when you log in and start up and install the Ocean Next 2.0 the first time, you'll be prompted to sign up for a MyRTI account. And it's free, and it's a tool that will help you in managing your devices and etc. So we'll have a quick look at what that is. Once you've signed up, it's a customer portal. You have access to calibration certificates, relevant manuals, calibration reminders, a log of measurement data, not a database as such, but a log of what measurements have been made. And to access it, the easiest way is to look at this symbol, the My symbol. If you click on there and you're signed up, it will take you to your MyRTI site, where you'll have meter information accessible, for instance. If you click on the meter information, you'll have a screen showing you what devices have you used as with your login. And here you'll have also a calibration reminder if it's out of compliance or if it's about to be due for calibration. You'll get a yellow or an amber light. But if you have a look at this panel, if you click on this one, you'll see the information about that meter. With that meter, which probes have been used. These are the probes, the serial number of those probes have been used together with this device, this Piranha. Calibration, most recent calibration certificates are also listed for that specific device. And if you have a look at it, you can see that it's access to that PDF file, and you can download that with the information that you have that's supported right there. Also, there's a possibility then to have just access to software downloads, application notes relevant to this type of instrument, brochures relevant, and manuals relevant to that type of instrument to click on a button. And there is also the logs, the measurement logs, where you'll have a log like this created every on-off cycle or with an instrument. In this case, what we see here is the Piranha that has been used. If you click on one of these rows, you'll see that in this instance, we made 2 measurements in this so-called session. If we click on the measurement, you'll have an image of the waveform. You have all the data for the tube voltage, the kV, the exposure time, everything that was recorded, when it was made, a timestamp, and what beam quality was used for that specific measurement. If there was location information, if there was site information associated with this measurement, it will also show up here where that was made, which facility it was at. So, but that's only if that information is available at the time of exposure. Then we'll look at let's see what we had. Yeah, okay. If we look at this image right here, you'll see this is where we have something called tag. And that's if you use a tag in QuickCheck, for instance, we noted that that may be some information that you want to record, that you're doing using a certain phantom, or you're using a certain technique, or trying to recreate some. So then you'll be able to find that measurement also in the web interface. That's where we have that tag functionality in there. All right. Also then, there's a possibility here of quick access to support. Well, you have all the support contact details that are available to you almost 24/7 if you run into some kind of trouble along the line. So this is then something that we've also found to be useful with the most immediate one is the calibration reminders and having direct access to the calibration certificates, which once in a while somebody takes care of them and files them, and there's sometimes tricky to find. Here you have them accessible at the click of a button in this interface. And we're hoping to develop this interface even more to provide even more support in the not too distant future. All right, so with that piece of I'd call it software, which we hope to be, which we think will be useful, it's time to ask for questions, if there are any questions out there.
Yes, Erik, there were a couple that came through. Being mindful of our 60-minute mark, I want to see if I could get through a couple of these with you, and then I'll send any additional offline. But first question, does the MA cable measure voltage or MA on the generator controller board?
The MA test point cable measures the voltage, but converts it according to a conversion factor that we know each modality, each X-ray machine has its own conversion factor there. So we store that in the connector. So the software can do that conversion from voltage to MA.
And is QuickCheck a separate software, or does it require a license?
QuickCheck is part of the Ocean package, but it is license free. So you can download the Ocean software, and with no extra license or anything, you have access to QuickCheck, and you can do your measurements as any other instrument, license free. If you want to use the templates that we looked at and the favorites, test view, then you'll need to look at a license.
Fair enough. And with that, Erik, I certainly want to thank you for your time and the presentation today. Again, I want to encourage everyone to visit today's sponsor, RTI Group. You can learn more about the products that they provide our industry by visiting rtigroup.com. Quick reminder that you can obtain your CE certificate by completing the post-webinar survey. You're going to receive that survey via email in 1 hour. Click the link, fill out the survey, submit it, and you'll be able to download your certificate from your computer. We do have another great webinar for you next Wednesday. Go ahead and hop over to our upcoming calendar so you can register for it and other webinars in the future. That URL is webinarwednesday.live. All right, Tech Nation, make it a great Wednesday. We'll see you back next week.